right, welcome back. Today we have a special guest, Herman Ross, coming from Intel. Herman has been leading the development of CARLA, and you'll learn a lot more about CARLA now. But just a quick intro is for Herman. He has been working on autonomous driving and other related technology, both at Intel and Toyota Research Institute, and before that, during your PhD at the Center for Computer Vision at the University of Barcelona, right? Mm-hmm. So I think we'll enjoy hearing from experts in CARLA today.
Thank you, Juan Carlos, for the nice introduction. And thank you, everyone, for inviting me here, especially thank you, Juan Carlos, team for organizing everything, for giving us the opportunity to come here to present our work and trying to engage with you and invite you to use CARLA. So,
sorry, one quick organizational disruption. So, because our food came late, please go in small groups to talk once it's ready, and we'll try not to interrupt the talk too much.
Please don't start. Grab your food.
Why don't we do this first? That vertical part go,
Yeah.
and then this part.
That sounds good.
This part. Just go quiet.
Thank you.
And,
All right.
Great, thank you. So basically, I'm going to be introducing the challenges in autonomous driving simulation and how can we improve the democratization of autonomous driving simulation as an open source project. So this is the outline of my contents. Let me jump directly to the meat of the talk, the CARLA project. So CARLA is an open source simulator for autonomous driving. It's a tool based on Unreal Engine 4, which is the standard platform for creating AAA games, the games that you buy today, expensive games that have amazing graphics. So one of the particularities of Unreal Engine 4 is that it's open source. You're able to build on top of that. It has a very generous license, and that was the main reason for building CARLA on top of Unreal Engine 4. One special thing that I would like to highlight about CARLA design is that we put a lot of effort into making CARLA modular, scalable, and flexible. The idea is to be able to extend CARLA in a simple way, scale it up, running on the cloud, and being able to pretty much do whatever you need to do, modifying the framework in a simple way. Our goals for CARLA, the main one is democratization of autonomous driving simulation. So basically, if you want to do research in autonomous driving, we don't want you to need to have your own fleet of cars going around collecting millions of miles in order to do progress. I think it's very important to have a tool that allows people to test new concepts very quick without having to come up with such a huge infrastructure. So basically, we're trying to have small, humble groups doing progress in autonomous driving field through CARLA. Then, of course, simulation is also an amazing tool for accelerating research and development cycles. So autonomous driving companies can use also CARLA to test ideas very quick and see which is the best design for a given task. And I think CARLA is also a very good platform for this use case. And then something that we really care about is to have a standard platform in both academia and industry. So something that can serve as a kind of vet test for everyone to compare their algorithms, their agents, and overall their progress. So these are the three main use cases that are leading the CARLA development. So for all of you who haven't seen what CARLA is, this is a nice introduction. So we try to come up with realistic graphics as much as possible. So we put a lot of attention into the perception side. We work a lot into creating nice assets and materials. Our simulation is full of very versatile urban environments, full of details, and basically trying to come up with very realistic simulation, right? Simulating cities and all the behaviors that you can, all the agents that you can find in cities. So we have pedestrian, vehicle, cyclists, different weather conditions, intersection, traffic lights, traffic signs, pretty much everything that you need. So we put a lot of effort into coming up with nice different weather conditions and illuminations, and overall trying to offer the user a nice and complete experience. Here you can see that CARLA environments are pretty big. You can also get a lot of information from the simulator, including like metadata and ground truth for different perception problems. So for example, you can get semantic segmentation, depth estimation, the state of all the objects of the scene, 3D position, poses, and so on and so on. And we plan to keep adding information to the CARLA message system. So I would like to spend some time like thanking the team, CARLA team, because without them this simulator wouldn't be possible. So starting from our researchers like Alexei Dostoevsky, Vladlen Koltum, Antonio Lopez, and Felipe Codevilla, and then our main developer team, led by Nestor Subiran, Mark Garcia, and also our 3D artists. So we have a bunch of 3D designers helping developing all the materials that are free for the community to use. So all the 3D assets that you see in CARLA, all the worlds, all the environments, you can take them, you can do whatever you want with them. Those are yours to take them and work with them. So here at the bottom you can see our team led by Xavier Godina. Then I would also like to take some time acknowledging the collaboration of the Computer Vision Center in the creation of this project. So originally, CARLA was developed in Barcelona, supported and funded by Intel. Now we are transitioning to be part of the Open Source Vision Foundation. So the Open Source Vision Foundation is going to serve as a non-profit umbrella for different open source projects like OpenCV, Open3D, and CARLA. And basically, our mission is to promote research in the field of computer vision and machine learning. So, yeah, we hope to hear from you. Hopefully, serve you as our main customers to do great research together. So now moving to more technical details. So this is the overall design of the platform. So we decided to design CARLA as a server-client architecture. So basically, the main purpose was to enhance flexibility. So the server, CARLA server is pretty much an oyster with just basic functionality so that we are able to scale it up as much as possible. Server is performing basic stuff like rendering, logging information, logging your miles, and providing you with statistics. Then most of the hard processing happens in the client side. The client side could be distributed, could be running in a different node across your network, and is in charge of running your software stack. So basically, your autonomous driving stack runs in the client. The client offers like a kind of abstraction layer to communicate with the server, basically allowing you to send commands to the server, setting up the whole simulation, deciding on the scenarios, and then once the simulation is running, you basically receive like sensory information or any kind of information that you subscribe to, and send commands back to do the actuation. We're transitioning now to a new model where we have a server multi-client environment, and basically different clients can take care of different actions or different elements of the scene. So there is going to be one client that takes care of controlling all the traffic, and then different clients connected to pedestrians, controlling the pedestrian, moving the skeletons, other clients controlling different cars, and so on and so on. This is going to be a more flexible design. Then, things to highlight about CARLA. So we have a very convenient user API that is Pythonic. So basically, you can control everything in Python, which is very convenient for machine learning. We have a very configurable sensor suite that it's growing continuously. So we have RGB cameras, we have LiDAR, you can get depth maps, semantic segmentation, and so on and so on. As I mentioned before, we have custom-made assets, and this asset library keeps growing. This is a public library of assets that we have created for the community. So you are free to take them, modify. Our license is MIT, so you can do whatever you want to do with the assets. And then a diversity of weather and lighting conditions. So I think this is very important, especially for when you use perception in driving, something that is skipped sometime, but we consider critical, especially for transferability from virtual world to reality. Then, going more technical, like basic step, how can you run CARLA? This is something that people ask, and it's pretty simple. So in the good old days, you download the binary, you uncompress the binary, you run the server using the top command. You have to specify like the number of physics steps per second you want to achieve, for example, 10 steps per second or 100. So depending on how much you want to run your physics simulation, you define a word port to connect, and basically then you run your client, and that's it. Now in the new days, we have improved this process a little bit, and everything is Dockerized. So you don't even need to download CARLA. You can automatically like fetch the container from the cloud, run it, associate it to your preferred GPU, and you can have in your cluster 25, 40 CARLAs running in parallel to do reinforcement learning. So for that, you only have to go to the client code and set up a couple of parameters. So for example, if you want to run synchronous or asynchronous simulation, so for example, if you're trying to train something like A3C, you will probably go for asynchronous mode. If you're trying to run a very heavy perception stack that takes a lot of time, so you probably need some synchronization with the server so that the server can wait for you until you are ready. Then you can set the number of vehicles in the scene, number of pedestrians, different weather conditions, and the quality level of the graphics. So now we provide two quality levels. High level, that we call epic, if you need to do heavy perception, and low level for reinforcement learning tasks and imitation learning, where you need to run like faster real time, like 100 frames per second and so on. Then you just have to set up your sensors. So from cameras to LiDARs, whatever you want to set, you give the pose of the sensor with respect to your car, and you're ready to go. And when you finish that, this is basically what you get. So on the right, you can see a view from the client, extended with a couple of extra windows, showing like depth map and semantic segmentation. You can also see the position of all the agents of the scene, speeds, and so on. So CARLA provides you with a lot of messages that you can use for reinforcement learning, imitation learning, or overall to learn your driving policies. So that includes like 3D bounding boxes and 3D position and poses of all the objects of the scene, the type of the object, the state of the object, for example, that's very useful for traffic lights, the speed of the different objects, accelerations, and so on and so on. You also get important information for policy training. You get the collisions against different objects, how severe was that collision, the amount of invasion into an opposite lane, the amount of invasion into the sidewalk, and so on and so on. So very important metrics to come up with a kind of a score on how good your simulation, how good your driving is going. So I hope that so far you are engaged and thinking that CARLA is a good project. If that's the case, you can find us in our website. Please check out our blog posts and news. There we announce all the new releases and what we have added in the new release. We have a new release each month. There's also a getting started video that you can check in order to know how to install CARLA and how to run it with different options. And then join our Discord community. Our Discord community is basically where all our developers are helping people, solving problems. If you want to add a new functionality that you need for your research, you basically go there and say, hey, how can I do that? Who can help me doing that? And usually you get a lot of attention and get feedback. Of course, check our documentation and GitHub repository. Then I would like to highlight the point that CARLA is very well alive and we are growing. The brain is getting bigger. We are planning to stay around for a while. So far, the project has been for more than 300 times. We have done more than 28 releases in the last year. Multiple issues provided by the community has been closed and solved. So we get a lot of feedback from the community, and we try to solve all the issues and take into account all the suggestions, basically because we want to make CARLA the standard for academy and industry in the field of autonomous driving research. Our Discord community is quite active. We have more than 100 users now, and it keeps growing every day. So I would like to invite you to join our community and please engage in the CARLA development so that together we can create the new standard for simulation autonomous driving. So as an example of this, I would like to show some good contribution from the community. Like, for example, the LiDAR implementation was provided by Anton Pechenko from Yandex. And on the right, you can see our new integration with ROS that was created by George Lauren from Valeo. So both contributions from the community. So that's a proof that the community is engaging quite heavily, with the development of CARLA. And of course, none of this could have happened without the support of our sponsors. So I would especially like to highlight the members of our CARLA consortium, Toyota Research and Intel. We have periodic meetings, and we get feedback from the industry, experts in industry, to kind of guide our development and our roadmap. They also contribute with very generous donations, and sometimes even with code and manpower. So thank you. I would like to again thank our sponsor. Let's start with the cool part. So how people are using CARLA in research. So these are our 3 main use cases right now. This is what people are doing right now. So CARLA is used to design and learn new driving policies, to simulate, to try to do simulation to real policy transference, and to do autonomous driving perception. So I'm gonna talk about these 3 points now. So probably the first use of CARLA was our original paper, where we tried to come up with an analysis of how different policies kind of degrade in different conditions. So basically, we trained 3 different types of algorithms. So one based on a typical autonomous driving stack that is modular and is composed by a perception stack, a planner, and a controller. And then we tested against more modern techniques based on imitation learning and reinforcement learning. So here you can see the results of the modular pipeline during its testing stage. This was basically a combination of the 3 stages that I described before. So perception stack based on semantic segmentation, object detection, plus a simple planner, and some PID controllers to do the final control. This one is conditional imitation learning. So it's basically it's conditioned by a topological planner that sends the high-level route, and then basically conditioned to those actions, it has to find the best way to execute the action. Overall, imitation learning works relatively well at the level of the modular pipeline, and it's a bit more flexible. So you see that it's able to adapt to different conditions very nicely. So here you can see our test in different scenarios and different weather conditions. This one is performance learning. This one is a bit surprising because it comes with very weird behaviors, like it's able to overtake and so on. But so far, we didn't manage to make it work so well. We're working on that. But it comes with very creative things. So the exploration space helped the algorithm to find interesting behaviors. But it doesn't respect rules very much. So it finds. I think I'm going to stop it here. OK, so this is the important part of this project. So our new test set. So basically, the standardization of the behavior of different policies. So we came up with this progressive test. In the first block on the left, we test on the same conditions that we use during training, so same town and same weather condition. The second block are tests for a new town. So we keep the weather conditions, but we change the scenario. The third block describes what happens when you test in new weather conditions that you didn't see during training, but same scenario. And the rightmost test refers to what happens when you test in a new set of scenarios and a new set of weather conditions. For the rows, we have tasks of increasing difficulty. So the first task is just going straight. So basically, the task here is to move from point A to point B to the goal. And in this case, it's just the goal is just ahead of you, which should be relatively easy. The second task is one turn. So basically, your goal is always going to be one turn away from you. It could be a left turn, a right turn, whatever, but you're only one turn. The third one is just free navigation. Basically, you don't know where the goal is. It could be 1, 2, 3 turns away. It's just free navigation without dynamic objects. So basically, the road is going to be just for yourself. And the last row is the real thing. So basically, a scene full of objects, cars, pedestrians, and so on. You don't know the complexity of the target. The target could be like 20 hops away. This is the real thing. What you could observe here is that even for the simple task of going straight, even for the training conditions, agents don't perform at 100%. Okay, so we were not able to train agents to do 100% well this task. They still fail. And when you take it to the more complicated scenarios, more complicated environments where you have different weather conditions that you have never seen and different towns, you see that the performance drops quite a lot for all the techniques, for the modular pipeline, for the imitation learning, and for reinforcement learning. And this trend keeps being true for all the other tasks. If you check the last task, the one that involves dynamic elements in the scene, you see that the performance in a new town for new weather condition is pretty low. So only 44% of the time we could complete the simulation for the modular pipeline. The imitation learning pipeline is performing relatively well. So we consider our modular pipeline a kind of upper bound for this kind of cases because, well, it has been engineered to perform well. And in this case, imitation learning is able to replicate those results. But if you pay attention to reinforcement learning, you see that it's performing really badly. So we were not able to generalize using imitation learning using a decent amount of iterations during training, so more than 10 million. So I think this is one of the challenges. How can we train reinforcement learning methods using CARLA?
Quick question. Why does the IL outperform MP like on the first?
And in the left condition?
Yeah.
So yeah, it could happen. So actually, IL is more flexible sometimes than the modular pipeline. So the modular pipeline is based on certain rules that sometimes don't work for some scenarios. So basic on physical constraint. So sometimes it could actually get stuck, like maybe it was too fast and get out of the curve and get stuck and couldn't complete the simulation. While the imitation learning is usually smoother and is able to, even though it's not so much, it's not so consistent. So sometimes makes mistakes. It's kind of smoother, so it's able to take the curves in a more decent way. So I think one thing I will highlight of the imitation learning is that usually it's smooth. It's more flexible in new scenarios, but it's not as consistent as the modular pipeline that is based on hard code rules.
Can you describe what the modular pipeline is?
Yes, so the modular pipeline is based on, the perception stack is based on semantic segmentation. So we segment like the important classes of the scene, for example, eagle lane, lane marking, and then all the objects like pedestrians and cars. So from there, we try to predict waypoints using that information. And from the waypoints, we have a planner that decides how to approach the new waypoint ahead. So basically your speed, your pose, and so on. And that information goes into a PID controller.
Is that RGB is all in 3D or 3D?
This process is done in 3D.
You have semantic segmentation for phone time.
We have semantic segmentation and we back project it to 3D. We have multiple cameras and we also have the information coming from the depth sensor. So we can back project it to 3D. The waypoints. So basically we do the semantic segmentation in 2D to come up with some waypoints, and those waypoints are back projected to 3D.
I see.
Yeah.
Follow-up question. The algorithms perform generally better in new weather than the training condition. Is there a reason for that?
Yes. Actually, this is a kind of design flow. So basically, these subcategories of weather are not as challenging as the training weather. So basically, we just did a split But in this design, the testing weather were not so challenging.
What makes the weather more challenging?
Usually, if you get very far away from the illumination condition that you train on, that's more challenging. So for example, in this case, we have very severe raining condition during training, and we don't have such a severe raining condition during testing. We just added like light raining and so on. So we probably have to update this to kind of have something that is more consistent. Yeah, we have been thinking about this. Good. So, okay, basically the point I was trying to convey is that we are far from solving this problem. This was one of the starting points to kind of define the baselines for policy learning in autonomous driving. Then this work was extended by Felipe, adding the conditional imitation learning that we have seen before. So basically, they propose imitation learning policies that are able to be conditioned into a topological map. So the system receives, as I explained, the set of rules or the set of direction that need to be taken in order to get to a goal. So for example, the same thing that you will get as a driver when you use Google Maps, right? So turn left, make a right, and so on and so on. And basically, the system has to find the way to execute that. Then this is a follow-up that came live last week by Andreas Geiger's lab. It's a pretty nice work. And they definitely improve upon our work on imitation learning. So they propose this approach based on affordances, image affordances, that is kind of more generic and generalized way better than just using like perception. So they define a set of 6 or 7 affordances based on your distance to the center of the lane, and so on and so on. And results are pretty amazing. So this is not my work, so I'm not going to be talking a lot about it, but I got permission from the author to show it as a kind of good use of CARLA and how CARLA has been used in the community. And we are pretty happy to see like these kind of results popping up and people using the platform to do good research. So let me skip a little bit to the result. So they are even taking into account traffic light and stop signs, something that in our original work we couldn't do, especially for reinforcement learning. And overall, the results are very good and generalized super well. I will show you the results table now. And I really believe that the idea of using these kind of affordances work very well for learning driving policies. And it's something that gets a bit closer to how like typically a planner works. Okay. So here you can see the results of the new method at the right column called CAL. So basically, we focus on the most challenging scenario. You see that generalization is way better than what we got before with conditional imitation learning and reinforcement learning. So basically, they managed to use our platform to do good research and come up with a better idea. And this is the purpose of CARLA. The purpose of CARLA is to have this common test bed so that we can all test together in these kind of scenarios, quickly prototype something new that works better, and disseminate that information. So this is what we would love to keep seeing, like more people using the platform, coming up with new methods that are able to drive safer and in more challenging conditions. Then second use case is simulation to real, so policy transference. So this work is by Matthias Müller. He did it during an internship at Intel. And basically, he managed to train a policy in CARLA and transfer it to a real car, well, to an RC car, in different conditions, without any kind of retraining, any kind of domain adaptation, nothing. So using just modularity and abstraction. So basically coming up with a different input representation based on semantic segmentation and using that representation for both CARLA and the real world. So I think these results are very interesting. So these, I think these results are from South Arabia. These ones are from Munich, but you can see that actually is able, the RC car is able to follow the road, reach the goal. So I think this research line is very interesting. We are actively working on this. So ideally, towards the democratization of simulation, we need to have a robust platform that is able to also do this kind of transference. So it doesn't matter if you have a good simulation, if in the end you don't know how to reuse that knowledge or that agent to make it work in the real world. So basically, we need to think on situations and techniques that are able to get transferred to the real world. And I think CARLA is a very good platform for this kind of task as well. So also CARLA has been used for perception in autonomous driving. So recently Lyft, in partnership with Udacity, came up with the Lyft Perception Challenge. CARLA was the main platform for students to use. Basically, the content was about semantic segmentation, role semantic segmentation, how to do navigation using that semantic segmentation. It was a super huge event. I think hundreds of students sign up for the event. They have a very huge community, a lot of interaction, courses, classes. It was a very nice experience. We were very glad to get invited for the community to use CARLA for this kind of activities. Here you can see some results of one of the top of the leaderboard. Of course, you could have done the same with a real platform, like you acquire some data, but how comfortable it is for people, for students, to take the simulator, download it, and generate your own data set, start testing things by yourself without having to go out there to do all this hard work. Then I'm gonna move about what is coming next. So our roadmap. I think people have been asking us like, what's next? Are you gonna include this functionality? I need this functionality for my research. When is this gonna be ready? So I would like to share with you what we are planning to do and what are our motivations to prioritize the features that we are developing right now. And of course, I would love to hear your feedback and to know more about your interest. So basically, our project is guided by the community. So CARLA is an open source project. Basically, people leave us feedback as GitHub issues or feature requests. We also get a lot of feedback from our industry partners. So people in our CARLA consortium usually participate in meetings and trying to add new concerns and prioritize tasks that for them are important. So basically trying to come up with something that is still generic and doesn't give a specific entity a competitive advantage, but that is good for the sake of autonomous driving simulation. Our roadmap is going to be public and by next week. So we want to share it with the whole community and what are our timelines so that people can. We want to increase transparency in CARLA. Basically, it's composed of these 5 core lines of development. So we have our CARLA core, which involves like making the system more stable, improving communication, coming out with a non-rendering mode, and this kind of tasks. Then automatic content generation is also one of the most important lines in CARLA. So we're trying to generate content automatically, new scenes and scenarios, procedurally generated from OpenStreetMap. I will talk a little bit about that now. Integration with new tools, so integration with other open source projects like ROS, or Coach, Sumo, and so on and so on. So we want to be part of all those open source projects so that you can use CARLA in different setups, and CARLA can be a really useful tool. Then sensors, we try to keep improving our sensor simulation, making better LiDAR simulation, physically plausible cameras, and so on and so on. And for sure, our asset library is becoming quite huge, and we feel very proud about it. We plan to keep extending the library with more assets so that people can reuse it for their experiments and creating new kind of situations. I think so far we're doing a good job for that specific item. Then with all of this, all the feedback from the industry and from our user, it was a bit of a mess. So what we decided is that probably the best way to kind of guide the development, like make sense out of this, was to come up with milestones. So we now use a milestone-driven development philosophy. What does it mean? So basically, we define a milestone, a big project. Through that big project, we have to come up with all the functionality that is required to run it. In this case, our first milestone is called the CARLA Driving Challenge. So the CARLA Driving Challenge is going to be a driving challenge for multiple teams running on the cloud that will happen in conjunction with CEPR 2019. The idea here is to show that your agent is able to drive safely in a diverse set of locations and conditions. So we are procedurally generating these scenes based on real life scenes, like from Palo Alto, Boston, and so on and so on. And then we are taking as our scenarios NISTA pre-crash events. So we went through the NISTA white paper, and we selected the most important pre-crash scenario. We're simulating that in CARLA so that your agent has to show how can go through like really complicated situations. All the agents are going to be evaluated in terms of performance and safety and behavior. We're coming up with the right metrics. We are also open to feedback in this respect, because I think for this case, metrics are one of the most important things on how to evaluate safety and how to evaluate the performance of your agents. But this is it. So basically, right now, this driving challenge is kind of guiding all our development for the next year. We expect that the development of the driving challenge will be finished by mid-February. So now I will move to the individual items. So our core line, right now in our core line, we're mainly focusing on the control of all the agents of the simulation. So basically, many people requested this feature. Like, people want to be able to control all the agents of the scene, because that's useful for like testing different situations that requires interaction between agents, right? So you're going to be able to do that in 2 weeks, more or less. Basically, through multiple clients, you could connect and take like possession of different vehicles, pedestrians, and so on, with our new communication protocol. We're also coming up with something more flexible for the communication based on RPC. Also out of core scene, so basically you can download new scene as a DLC, which is going to be one of our big challenges for next year. So you don't have to recompile CARLA. There's new content. You just have to download it, and you can run your simulation there. Also, we're going to allow for more flexibility in the initialization of agents, so people are going to be able to design the initial state of the agent, speeds, and so on, something that right now is not possible in CARLA. For all of you who don't want to make use of perception, we're going to be running a non-rendering mode that is going to be able to run way faster than real time. So for all of you who are more interested in control and planning, we're adding experience logging and playback, so that you don't have to be in front of the simulation all the time. You get your summary of statistics, and if you want to check those cases where your agent was crashing or making this infraction, you can just click a button and then replay the experience and see what happened there. So I think it's going to be a very useful tool. we're coming out with a new advanced physics and terrain simulation. So basically from client side. So we are coming up with a new sensor that is able to provide you just the basic information that you need in order to run physics simulation from client side. So you can come up with your own physics simulation the way you want. Implement better physics models. And we're always working on improving the performance of the server. So basically trying to come up with better, faster behaviors in the server side so that you can run way faster than real time. And this is especially critical for reinforcement learning tasks and so on and so on. Then here you can see quickly an example of what we're doing to control multiple agents. This is still in development, but all the functionality is already there. It's going to be added to master soon. But basically, the pieces are there. We are already able to control multiple agents from the client. So this is going to be one of the big releases of the summer. Then, as I say, we have worked a lot on improving the performance. So we have two different rendering modes, like low graphics and epic. So in low graphics, you can get like up to 70 or 80 frames per second, which is very good for reinforcement learning tasks and training this kind of methods online. And if you need to do something that is more related to perception, you can always use our standard epic mode, which will give you up to 20 frames per second. So we have been working a lot on this. Then procedural generation and content generation. So one of the big things that is coming is our integration with Sumo for definition of scenarios and traffic patterns. So we are working actively in the integration of this tool with CARLA. And that's going to allow you to easily define your traffic conditions in a couple of clicks. But what we are more excited about is the procedural generation of scenes, right? So right now we have two efforts. We have been creating a standalone tool to process OpenStreetMap and generate CARLA scenarios. Then, since that's kind of a big endeavor, in parallel we came up with a surrogate. So this is a workflow based on City Engine. City Engine is not an open source tool. It's a private tool. You need to buy a license. But in the meantime, we thought that it was quite convenient to have something to generate scenes. Basically, we define a workflow on top of City Engine to create CARLA scenes. And you can see that in this video. So the idea is that before, to create a scene for CARLA, that took us around like 1 month. But now with this new workflow, it takes us less than 1 day. So you can select a region of your map, I don't know, let's say Stanford campus, and then through some basic manipulation, you can procedurally generate the content and then keep adding like miscellaneous objects like trees, vegetation, buildings, and so on and so on. And you can end up with a very nice scenario. So I'm going to skip so that you can see the final result. I think it's quite nice considering that before this used to take like 1 month of a specialized person to do this. Now it takes less than one day, and pretty much anyone can do this now. Of course, we're working on keep like improving the automatization of the process. So eventually, we would like to be totally like procedurally generated and with zero human intervention. So we are working in improving our sensors, like with new physically based cameras, GPS simulation, and so on and so on. So you can definitely contribute to this. We will be really thankful. Just to highlight that our integration, we have been extending our integration. So right now we are connected to platforms like ROS, Coach, which is an open source platform for reinforcement learning and imitation learning based on TensorFlow. OpenAgym, we're working on Sumo integration. We are also trying to get integrated with hardware like steering wheels and so on. I'm going to skip this because I want to leave time for questions. So I think one of the main points that I would like to convey today is like how can you contribute to the project? Many people are asking us in our channel, like, how can I start? I think it's relatively easy. So my recommendation is that you join our Discord community, following that link. There you will have access to all our developers and all the members of the community. You will see that the community is a hive of activity. Like people are asking questions related to their projects, people coming up with great ideas of how to implement new things and what is exciting for them in terms of research. I would recommend you to subscribe to our mailing list, read our contribution guidelines. You can contribute with small things like feature requests that are interesting for you. We definitely appreciate when you share your resource with us because that's really motivating. You can provide us new functionality through pull requests. And definitely you can also help us like providing new contents, like new assets and 3D models. We love it. Soon we're going to have our first sprint, code sprint. We're planning for that now. Hopefully it will be out by next month. We expect you to participate. We would love to help you out to understand how CARLA works and how you can use it for your research to develop new functionality that you really need. That's it. That's the end of my talk. So thank you very much for listening to me today. I would like to thank the team for making this happen. So thank you.
Time for questions.
So the procedure generation seems really cool. Have you thought about parsing Google Street View?
Yes, but I don't know. So one of the main concerns that we always have is about licensing, because we need to keep everything as open as possible. So I don't think parsing OpenStreetView is legal.
Is illegal?
He doesn't know if it's legal.
Oh, it doesn't know.
But I'm pretty sure it's not.
Yeah,
Like-
well, you could crawl it. I don't
You
know.
could. You probably wouldn't.
Right.
Probably you could do it, probably I couldn't do it. Or I shouldn't do it. So OpenStreetMap seems better. So our plan now is that, well, you know that OpenStreetMap doesn't contain all the information. But what we're trying to do is, instead of modifying that information a posteriori, where the mesh has been generated, we're trying to annotate OpenStreetMap a priori. So basically, we know that the information that we need is not there. For example, the width of the lanes is not there. Why don't we add it a priori and then let our procedural generation engine to generate the right thing?
Hi, and maybe you mentioned this, but I missed it. So in the case of the imitation learning, how do you generate the expert behaviors for the training?
There are two methods. So the first method was a lot of people play the game, but then we just came up with an autopilot. So the autopilot is driving in a correct way, and noise is injected. So basically, the autopilot has to compensate for the noise. So you recover from different situations. So correct behavior plus noise, like real-time noise. Like when you're acquiring data, you inject some noise. Like if some crazy people were taking control of your steering wheel.
Yeah, I saw actually on all the video and the things you showed, all the traffic are single lane, and so there's no like merging or.
No, actually there are multiple lanes and there's merging as well. But this use case is something that we are not able to solve yet. Basically, it's something that we are not working on, or we are not showing, because we are still trying to solve like the simple cases, like how can I just not crash against this object, or how can I respect the traffic light. But definitely, for the CARLA challenge, one of the things we're trying to put a lot of emphasis into is like lane merging, intersections, like unprotected left, like how do you do unprotected left the right way. But so far, I mean, this is a challenge. This is a real challenge. It seems easy, but like these kind of policy learning methods are not able to deal with that yet very well. So it's a problem for you to.
If I want to like do that, and I'd say I download CARLA today, how much work will be needed for me to like create a scenario like a multi-lane and multiple cars and stuff like that?
So right now, as for today, it's kind of a big challenge, to be honest. So we have some documentation on the website. Some people have done it. I think some people from University of Michigan actually have a lot of time in their hands, and they actually did it. But it was very challenging. what we are doing now using City Engine is to simplify this process. So basically, in the end, you just have to click here, select the map with multiple lanes. It gets automatically generated. So you will probably need to wait for that or suffer some pain right now. It might take a couple of days to come up with a scenario.
So just to make
It's clear. The problem right now is the assets. You don't have a, or
it's not the assets. It's like you want to add new content that might not be like a 3D asset, but like a scene definition or something. It's like, how do you do that? How do you bring real information into the simulation? What's the easiest way? So if you don't have the knowledge to do 3D modeling, like what's the easiest way? If you're an Unreal expert, for you it will be very easy. You go to the editor, you modify it, add a new lane, and it's solved. But usually people in the machine learning community and artificial intelligence don't have this kind of knowledge, so for them it's very complicated to go to the Unreal Engine editor and add like new lanes or to change the properties of the scene. So we're trying to simplify that a lot for them. I think that's one of the
If I also learn Unreal in principle, it's fine. Right? It's possible to do.
Definitely. Yes. I mean, people without Unreal knowledge have managed to do it, like after a lot of hard work. But it's not that, you know, you're gonna learn a lot, and you will get our support in the process. But it will take some time, a couple of days at least.
Following up on that question, what about freeway driving?
Yes.
And overpasses and 3D features, roads coming up over and under one another.
So that's gonna be part of our challenge. We're working now on the design of freeway scenarios. Because before we wanted to focus on complex situations in urban scenes, like you know, unprotected like intersections. The reality is like we realized pretty soon that machine learning is not at the state of solving that right now. So we need to come up with better infrastructure. So we need to come up with better ways of parallelizing the simulation, running this thing massively in clusters so that you get enough training data to deal with these scenarios. So we kind of step back a little bit and say, okay, let's gonna go for something important but easier, like highway scenarios and so on. That's definitely gonna be in the challenge.
one more question. So do you plan to ask the challenge participants to make their code open source? Or what's the requirement for participation?
So we didn't plan to impose any constraint on the participation. Obviously, we encourage people to open source their code and their solution, but we probably expect like industry participants getting involved in the challenge, and probably they don't want to share the code with us. So we actually have conceived an architecture, an online cloud architecture that we will be able to protect their code while they run without exposing it to us or anyone else. So in theory, in principle, we are not going to ask people to release the code, but we are going to encourage people to do it.
I guess that's connected with the new capability of controlling multiple agents from different clients.
Yeah, exactly.
So, and that's actually a feature that we probably would make extensive use of.
Yeah.
So if that's coming up, that's something we will
Yeah.
definitely use.
So I didn't want to explicitly give timelines for things, for items, but that's very much on purpose. This functionality of controlling multiple agents is coming soon, and by soon I mean probably next month. The rest of the thing, like for example, the procedural generator scenario will be coming after the summer. I hope that you can give us some feedback and participate in the future development.
All right, I think maybe one last question.
I'm curious about the state of the art of simulation for autonomous driving. Now, I guess there are 10, 20 car companies, and I'm guessing each one of them has simulation. So are they all using the same simulator, or do they have in-house simulators that they jealously guard and are private, and are they 10 times better than yours? Or so that's the questions about the competition, your competition.
Yeah, we don't see them as a competitor. I mean, we are very happy to participate in this scenario of autonomous driving, but for us, the main target is to come up with something that is open and that people can use. So definitely they have their internal simulation efforts, and they have their own thing. Most of them that just build it in-house. To be honest, the industry typically cares about starting with simple problems, like for example planning. They don't do much of perception in simulation. They just care about high-level representation of the scene, how to learn their planning algorithms, and how to do system verification. So for them, one of the main use cases right now, like verification, verifying that your systems, your driving stack is still working. For us, it's kind of different. For us, we care a lot about perception. We care a lot about the full stack to give you something that you can use for training, evaluation, and overall something that is free. But in terms of capabilities, well, NVIDIA is building its own simulator. It's pretty nice. Waymo obviously has its own simulator, but it's more focused on the planning side of things. Zoox was one of the big companies like investing a lot of effort in simulation, also based on Unreal. Yeah, pretty much everyone has an internal simulator. The question is, can we have an open? You can have internally your own simulator, but could you also use this open source simulator to kind of put results in context? So basically, when you claim that your software stack is amazing, could you prove it? Could you just come over, plug your driving stack, and prove that you are better than all the others?
Thanks. All right, I think that's all the time we have. Let's thank our speaker again.